And again, the fact that this industry of venture capital is very strong in Israel, and many R&D centers established by leading multinational corporations. Just to show you some example, you all probably heard about the Pentium processor, the Centrino processor, voicemail, voice over IP, firewall, discom keys that everybody holds in his pocket. All these technologies were developed in Israel. And in the area of biomed and medical devices, medications for multiple sclerosis, the Copaxone, medications for Parkinson's disease. Somebody told me that Israel is very strong in imaging. The CT, the 64 slices CT was developed in Israel by Philips team, and many other things. The defense and security industry, this is a strong drive forward, and Israel, for instance, in the space industry, Israel, this tiny country, belongs to the exclusive club of 7 countries with proven record of launching and placing satellites in orbit. And missile technology, you probably understand that it is out of necessity, that we had to develop really unique technologies of how to cope with short-range and long-range missiles. So these these governmental policies and programs are executed mainly by the Office of the Chief Scientist of the Ministry of Industry and Trade. This is why I believe that in such congresses, politicians and those who make the decisions about budgets and national program should be here and participate in such congresses. Just a few examples of these programs. These are meant to answer about what are the missing factors. The missing factors usually are cooperation between companies and academy. Missing is the access to academic science knowledge, and always you lack financial resources for the R&D of generic technologies. Generic technologies that CEOs don't have the ability to invest in technologies that will bear fruit only 10 years from now. This is what the Ministry of Trade and Commerce does. One program is Magnet. Magnet is in Hebrew, stands for R&D, generic R&D. And it combines forces of the academic institutions and industry and finance them for long terms, for 5 to 6 years, in order to generate new generic technologies. Nobody wants product at this stage. So the Magnet program is all about synergism and creating critical mass and creating generic pre-competitive technologies. This is the symbol of Magnet, the synergism idea. 1 + 1 equals more than 2. This is the mathematics in Israel. The method is creating clusters of companies, consortiums they are called, in areas which are important in the international markets, in which we might have a relative advantage. And they are financed by millions of dollars for 3 to 6 years. Such consortium need to have a common vision, and then, like it was explained here very accurately by previous speakers, need to define the future markets, need to describe the technologies that are needed, the gaps, the technological gaps, and finally have an action plan to overcome those technological gaps. Another initiative is Magneton, which stands for a small magnet in Hebrew. It encourages one-on-one relationship between academy and industry. And it is, they finance such an activity for a shorter period with less money, for 2 years with up to $800,000. And the results of such a program in Israel in the last 10 years, they financed 220 projects, and there's more or less a steady state of 25 projects that are financed each year. They have roughly 50% success. Success means that you have continuing projects not financed by the government. Another initiative is NOFAR. It is dedicated to biotechnology and nanotechnology. The goal of this program is achieving a milestone that makes sense to an industrial candidate to further cooperate with the academy. Okay, this is the Technion's vision. It is actually, if you read it, I assume that there are many universities with similar vision. And this statement is important, but is more or less standard. Nevertheless, if you watch what happened in the Technion in recent years, we can point several really important discoveries that had a global impact on mankind. For instance, the data compression algorithm by Lempel and Ziv. This paved the way to the revolution of information technology. Nobel Prize winning of discovering the ubiquitin system, which is dealing with degradation of proteins. Another Nobel Prize in last year about the quasi-periodic crystals that nobody believed that they exist. And anti-Parkinsonian medication that I'll tell you a couple of words later, and other things, stem cell research and many other things. So Technion graduates are involved in every field in the country. They created Israel's industrial infrastructure and reinforced Israel's defense capabilities and pioneered technologies everywhere. What are the supportive mechanisms of the Technion itself? There are a few, more than one, and I'll just concentrate on the first two, the Technion R&D Foundation and the Technion Incubator. There are other institutions that help, that contribute to the same direction. But let's understand the Technion R&D Foundation. It has most important aspect of their activity is the Technion Technology Transfer Office, the T3 is called. And this T3 transfer office, what does it mean, technology transfer? It means the movement of knowledge and discoveries to the general public. And by the way, making revenues to enable further research. So this process from research programs to realization and making it profitable by creating startups and companies. It was described earlier, and this is more or less the same as it happens everywhere. And this circle of research and materializing the research and bringing it to commercialization creates revenues, and these revenues enable further research, and this is how the Technion operates. So you have different models of involvement, different levels of involvement in the process. And the Technion, you have here in this matrix, you can see different level, and obviously the lower line means the deeper involvement with taking operational role in this process of commercialization, and this is what the Technion chose. It chose to this model of up to elbows involvement. The strategy, the mission of the T3 is to escort breakthrough technologies from the initial point of discovery through the process of development and licensing to the formation of a win-win venture with industry, and actually it should be tailored to each and every project in a unique way. And this is what they do.